In this video, we are going to be looking at Waec 2024 Physics Practical Mechanics. So this is the second video I'm making on this practical. I've already made a video where I actually carried out the experiment, but in this video, I'm going to be using a cheat code. I'm going to show you how you can get to carry out this or perform this experiment without needing to carry out the experiment. So what you need to look at for is just the density of some melters. So that's how you have to look for, and also the density of kerosene. So if you have not watched the other video, you can search through my channel to watch the video, or you can click on the description of this video to watch that other video on how to carry out this experiment. Don't forget, this video is strictly for the cheat code on how to carry out this practical without carrying out the experiment. Do not forget to subscribe, like, comment, and share this video. Okay, so let's get into the business. So this is the setup we have, and these are the questions that follows through. So what we have to give you, say we're using the spring balance provided, determine the weight of the object of mass 50 gram in air. So we're going to determine the masses in air and all of that. Then determine the weight of the object when it is completely immersed in water contained in a beaker as shown in the diagram above, and record the weight W2. So we're going to record the weight W2 for this object. So the object, when it's 50 grams, first of all, put it in air and weigh it, and that's the procedure. So determine the weight of the object when it is completely immersed in the liquid labeled air. So this time around, we're going to record the weight as W3. So this is the liquid labeled air. In this practical, that liquid is kerosene. So we're going to utilize that the density of kerosene to work this out. Again, we are to evaluate U equals W1 minus W2 and V equals W1 minus W3. Repeat the procedure with the object of mass M is equal to 100 grams, 150 grams, 200 grams, and 250 grams. In each case, evaluate U equals W1 minus W2 and V equals W1 minus W3. So you can see that on our table, we're going to have the 50 the masses M. Then we're going to have the column for the weight in air, which is W1. Then we are going to have the column for the weight in water, which is W2, and the weight in liquid W3, which is kerosene. Then we're going to have a column for U and a column for V. So this is my table. So my table is going to look like this. So I have the mass measured in gram. That's what they are given in the question. So I have 50, 100, 150, 200, and 250. So these are the mass. So then we're going to have the weight W1, W2, W3, U, and V as required in the question. So the next thing we have to do is to determine the weight in air. So how do we determine the weight in air? To determine the weight in air, we're going to use the simple formula for force. F is equal to ma or mg. This time it's going to be the weight of the object. So I'm going to use the value for g. I'm going to use 9.8. I'm not going to use 10 for better accuracy. 10 is the approximate value, so I'm going to use 9.8 for that. So what I'm going to do, I'll just work out the formula, then I'll plug in the values, and then we'll work that out. So remember that these weights are given in grams, so we have to convert that to kilogram by dividing by 1000. So the weight F in air is going to be like this. F or W, you can just call it W, which is the same as force. It's going to be the mass times 9.8 as a result due to gravity. That since the mass has to be converted to kilogram, go to divide it by what? 1000. So what I'm going to do is this: all the masses, I'll just plug the masses. This mass, I'll plug it into this formula. I use my calculator to work that out. Record that here to 2 decimal places. So you have to record this to at least 1 decimal place, but I'm going to record them to 2 decimal places. That will be better. So I'll just get my calculator and start working this out. So I'm going to have, for the first one, I'm going to have 50 times 9.8 divided by 1000. So that's going to give me 0.49. So I'm going to record this as 0.49 Newton. Then the next one is 100. So I'm going to have 100 times 9.8 divided by 1000. So that's going to give me 0.98. Okay. Next, I'm going to have 150 times 9.8 divided by 1000. That's going to give me 1.47. Then the next one is 200 times 9.8 divided by 1000. That's going to give me 1.96. Next, I'm going to do 250 times 9.8 divided by 1000. That's going to give me 2.45. 2.45. So these are my weights in air. So this values here gives me my weight in air. So what I'm going to do next, now you can use the value of 10 if you want to. You can use the value of 10 if you want to, but for better accuracy, I decided to go with 9.8. So I'm recording all of this to 2 decimal places. So I'm just going to erase this part now. Then I'll work out the next step. Now you need to be very be patient with this. For the next step, we're going to make use of the formula for Upthrust. So the formula for Upthrust is equal to weight in air minus weight in liquid. This time around, my liquid is going to be water. So my liquid is water. And again, this Upthrust here can also be calculated as density of liquid. This time around is going to be density of water times volume of solid times acceleration due to gravity. So notice what I'm going to do here now. So this Upthrust that we are going to get is just going to fill into this part. This Upthrust here is going to fill into this part here for that of water. So when we get this, we can then evaluate W2. Notice what we want to do here. So we'll just get the value for this first, this column. We'll then come back and use this formula here to get the value. We'll do the same thing for this. So what do we do? The density of water is 1000. Okay, now how do we now get the density of, or the volume of the solid? We can get the volume of solid. We know that density is equal to mass over volume. From here you can see that volume is equal to mass all over what? Density. So this, I'm going to replace this by the mass times density. So this formula becomes U equals density of water is 1000 times the volume of solid. That will be mass of solid all over density of solid. Now I'm using, you can use steel or brass. Just go around or use your textbook, look for the density of some metals that are used to make slotted mass. So I'm going to use steel as, so I'm going to choose steel as the materials that are used for making the mass that I'm going to use for my experiment. So the density of steel is between 7,750 and 8,050. So you can choose any of this one. Just go with the simplest one. I'll go with 7,750. So that's what I'm going to do. 750. Now times 9.8. So notice what I've just done now. Okay, you get that. Now because the masses are in grams, I have to divide them by 1000 again. So once I divide by 1000, you see that this 1000 will cancel out this. Then I'm going to get my U from 9.8 m all over the density here, 7750 is equal. So I'm all you just need to do is to get the density of the metal that you want to use, and by using the formulas for Upthrust, you are good to go. So I'll just plug in my value. I'm going to have 9.8 times 50, that's the first mass, divided by 7750. That gives me 0.063. So I'm going to record 0.063. What I have is 0.0632. So I'm recording that to 3 decimal places. Okay, so that's cool. So the next one, just change the mass. I'm going to now change this mass to 100. As easy as that. So I'm going to put 9.8 times 100 divided by 7750. So that's going to give me 0.13. 0.130. So what I had is 0.126. So because I want to write them to 3 decimal places, and be careful of putting values in between, so of this point here. So I could have gone with 0.126. That will be easily detected. What I can do is I can have 0.125, 0.120. This figure here, this one here, take note of that. This one, when you are taking that, it cannot be approximated to beyond 0.05. So what I can get from here is 5. You can't go beyond 5. So because of that reason, I've totally converted that to 1.30. Okay, so I can go with 1.25, 1.30. That's okay. Those are marginal fractions. So don't go 1.31. Okay, so by then they will know that you have manipulated the value. So the next one I have to do now, I have to put 150. So I'm going to do 9.8 times 150 divided by 7750. So that's going to give me 0.896. So I'm going to take that to 0.1890. 0.190. Okay, so the next one I'll go to for 9.8 times, the next mass is 200 divided by 7750. So that's going to give me 0.25. 0.250. What I had was 0.2529, but I'll just take that to 0.250. So the next, I'm going to multiply 9.8 times 250 divided by 7750. So that's going to be 0.316. I'm going to take that to 0.320. Okay, so I'm going to erase all of this now. Then I'll go for the other liquid, which is kerosene. This time around, you're going to make use of the density of kerosene. The density of kerosene is 800. So again, I'm going to go this way again. Upthrust would then be equal to, so this time around, the upthrust is V as stated here. The upthrust is now V. That's what I'm going to use. Okay, so V is density of liquid, which is 800, times the volume of liquid. This time around, the volume of the liquid is mass all over the density of solid again, which is 7750. That's what we used. Okay, which is 7750. So that's the density. We are using the same density times 9.8. If I what you can just do to simplify your work, I should have done it with the other one. Just multiply 800 by 9.8 and divide it by 770. Just make it linear. So that becomes 800 times 9.8 divided by 7750. So that's going to give me 1.01. Okay, let me leave 1.01 m, and the m must be in kilograms. So I have to divide that by what? 1000 again. So what we'll just do now, we'll just press 1.01 times 50 divided by 1000. So that's going to give me 0.050. What I had was 0.0505. So I'll leave it to 0.050. Okay, so we are going to do it for the next one, 100. So I'm going to have 100 times 1.01 divided by 1000. That's going to give me 0.100. What I had was 0.101. So I'll take away that one and leave this one this way. So the next one is going to be, so I'm going to replace the mass. I'm going to replace the mass by 150 now. So I'm going to have 1.01 times 150 divided by 1000. That's going to give me 0.150. What I had was 0.151. I'm just removing the one better accuracies, okay, for better presentation. So the next one is going to be 1.01 times 200 divided by 1000. That's going to be 0.200. Then next I'm going to have 1.01 times 250 divided by 1000. So that's going to give me 0.250. What I had was 0.252. So I'm leaving it to this point. So now to get this part here now and this part, what we'll simply do is to subtract these ones. So to get this part here and this part, so to get this part first, we'll just subtract this from this and subtract this from this. So you're going to get all of this. So subtract this from this, or then you get all of this. So I'm going to work all of that out now. So I'm going to have 0.49 minus 0.063. So that's going to give me 0.43. What I had is 0.427, 0.43. So I'm going to leave it at to 2 decimal places. Next, I'm going to have 0.49 minus 0.050. So I'm going to have 0.44. Next, I'm going to have 0.98 minus 0.130. That's going to give me 0.85. And I'm going to have 0.98 minus 0.10. That's going to give me 0.88. Then I'm going to have 1.47 minus 0.19. That's going to give me 1.28. Then I'm going to have the same 1.47 minus 0.15, 1.47 minus 0.15. That's going to give me 1.32. Then I'm going to have 1.96 minus 0.25. That's going to give me 1.71. Then I'm going to have the same minus 0.20. So I'm going to have 1.96 minus 0.20. That's going to be 1.76. Then I'm going to have 2.45 minus 0.320. That's going to give me 2.13. Then I'm going to have 2.45 minus 0.250. That's going to give me 2.20. So I'm going to record that as, I got 2.2. I'm going to record that as 2.20. So this is my required table video. Don't forget, if you want to check out the experiment, click on the description. You'll see the link there to see how the experiment was carried out. So this is super easy. Don't forget to, as usual, subscribe, like, and comment on this video. So these are the trends. You can see the trend that this is increasing, this is increasing, this is also increasing, and this is also increasing. And then you notice that this is greater than this. These are what you have to see, and this is greater than this. For the same with this is greater than this, and this is greater than this. So for every aspect of the experiment that you carry out, this would always be the smallest value, while this will be second smallest, and this is going to be the what? Highest.